Hello everyone, I am Bhagdevi and today we will be discussing some fundamental concepts of operating system and programming. We will cover user mode versus kernel mode, system calls, compilers, interpreters and JVMs. These topics are essential for software development and help us understand how programs interact with the hardware and operating system. So let's see user mode versus kernel mode. User mode runs applications in Chrome and WhatsApp. Kernel mode runs applications such as OS functions. The basic definition of the user mode is it runs regular applications like browsers, games. It has restricted access to system resources. It prevents direct interaction with the hardware. Example Chrome crashes. It won't affect other running apps. So let's see about address space isolation. Each app runs in a separate memory space. One app cannot interfere with another app's data. Advantages of address space isolation is it prevents system-wide crashes. Now let's see the definition of the kernel mode. Kernel mode it gives full access to the CPU, memory and hardware. Kernel mode is generally used by the OS for critical operations like file management, process scheduling. So let's see the risk of kernel mode. A bug in a kernel mode can crash the entire system. So now let's dive into the differences between the user mode and kernel mode. User mode. User mode, it is in the access of user mode is limited. It runs all the applications. It is secure enough. It crash affect only one app. Now let's see about the kernel mode. Kernel mode have full access. It runs OS functions. It is risky if budgie. It can crash if there is a crash in a kernel mode, then it can affect the whole system. So for the examples of user mode, they are running and text editor, and example for kernel mode is OS managing system memory. Now implications of mode switching in OS. Every system call requires switching between user mode and kernel mode. Performance overhead. This mode switching adds a small delay. Security. Kernel mode is protected to prevent malware from damaging the system. Now, let's see the system calls, which is the bridging gap between user and kernel. System calls allow programmers to request OS services. Example, an app needs to read a file, so it calls the OS. So, opening a file. There is a privilege level transition. Example, opening a file. The app calls open function. OS switches from user mode to kernel mode. You OS open the file, OS switches back to the user mode. This ensures security control over the system resources. Example of common system calls are we have three system calls such as read function, write function, and fork function. Read function it helps in reading a file content. Write function it helps in writing the data to the file. Fork it create a process for writing the content. Performance consideration of the system calls. Blocking calls and non-blocking calls. Blocking calls, it waits until task completes. Example read function. Non-blocking calls. Continue execution without waiting. Example asynchronous API calls. Now, let's dive into compilers which are transforming code for execution. So we compiler helps in translating the full code at once. The execution is very faster in compiler. Error handling helps in detecting errors before the running. Example of compilers are Java, C, CPP use compilers. Interpreters. Now let's see about the interpreters. Interpreters help in line by line execution, and these are slower execution, and it detects errors at runtime only. So this is all about the interpreters. It reads a line of code and it translates the code into the machine code and then it executes the code. Interpreters execute code line by line without prior compilation. So they are responsible for slower execution. Now let's see the overview of JVM. JVM is called as the Java engine for the Java execution. JVM executes Java programs. So you can see first one is Java code and next it converts the Java code into the bytecode and then JVM will be translating the bytecode for further execution, and in this execution phase, the execution will be done. It converts the Java bytecode into the machine code and makes Java platform independent. Example, let's take a simple example of this. A Java program written on Windows can run on Mac or Linux without any modifications. And we'll see some memory management techniques. JVM uses garbage collection to collect and manage memory. It automatically removes unused objects. This prevents memory leaks and improves the performances. Java apps doesn't need manual memory management like CPP. Let's see the features of JVM. Bytecode verification and access control. In bytecode verification, it ensures the code is valid or not. And in access control, it prevents unauthorized access to a system files. Example, Java apps runs in a sandboxed environment, reducing the security risk. And now let's see the role of JVM in platform independence. The same Java program can run on Windows, Mac, and Linux without any modification. The JVM converts the Java code into the system specific machine code. Example, an Android app runs on different phone brands seamlessly. So let's see an example of real world example. We'll be taking a web browser which interact with the user interaction, and the code is written in a JavaScript. It is interpreted code, and system calls will be done for network request and web server kernel mode operations. Thank you.